Okay, a few of you have asked me for some help on the cheetah and antelope problem, the last problem from the homework. So let's take a look at this one together. All right, so a cheetah sees an antelope. Both start running at the same time. The cheetah trying to catch the antelope, get some dinner. The antelope runs at 27 meters per second, and the cheetah runs at 30 meters per second. The antelope gets a 200-meter head start. Assuming both continue to run at these speeds, notice they'll both continue at a constant speed. How long will it take for the cheetah to catch the antelope? So I have here my cheetah. My cheetah is going to be running at 30 meters per second. I also have an antelope. My antelope looks suspiciously similar to my cheetah, but is indeed an antelope this time. Also running in the same direction, I should say. This time, running at 27 meters per second. At a certain point, they catch each other, and so their displacements reach the same point, and that should reach exactly the same point, so let me fill that in. All right, the other piece of information that we learned here is that the antelope got a 200-meter head start. 200-meter head start. So the antelope started 200 meters past the cheetah. All right, let's list what we know. In this case, we have two different systems. So S equals VT is still going to be the equation we're using. So let's think about these different variables. We know velocity of the cheetah, so I'm going to call that VC, equals 30 meters per second. I know velocity of the antelope is 27 meters per second. I also know that I have some displacement of the cheetah. I don't know how far the cheetah is going to have to run in order to catch the antelope. That's not something that's given to me in the problem. So just like in math class, if there's something that's not given to me in the problem, I'm going to call this distance, or I should really say this displacement, x. I'm not sure how far the cheetah will need to go, so we're going to call this x. The displacement starts at 0, and then the cheetah goes some undetermined amount in order to catch the antelope. All right. Now let's think about the displacement of my antelope. Well, the displacement of the antelope is going to be that same distance, but subtracted by 200 meters. That same distance, but subtracted by 200 meters, because you'll notice that the antelope gets a 200-meter head start. So this is x minus 200 meters. All right. What I don't know is time, and that's what I'm looking for. I do know that the time for the antelope is going to be the same as the time for the cheetah, however, because we're looking for how long it will take for them to catch each other. So I'm looking for when do those times end up exactly the same. All right, so let's start putting together some equations. So thinking about the cheetah, I have S of C equals V of C, T of C, X equals velocity of the cheetah is 30 times T. I could put T of the cheetah, but I'm just going to put time. I'm just going to say time because we know that there's only one time involved. There's not a separate time for the antelope and the cheetah because we're looking for the point at which these times are equal. All right, and now I have my poor little friend, the antelope. Maybe they're just going to play. The problem doesn't tell us. The antelope will actually be dinner. All right, so S of A displacement of the antelope equals velocity of the antelope times time of the antelope. So S of A was x minus 200 equals velocity is 27 times time. All right, there's a few ways you could do this problem. The way that I was encouraging you to do during office hours and in class was divide both sides to isolate the time. I think some people were getting tripped up on this algebra because now you end up with some fractions, and I think some people were finding that a little tricky. So let's use maybe a slightly simpler way. We notice that x is equal to 30t. And I notice that in my second equation, I have an x. So why don't we just plug in this 30t where I had x, because x and 30t are equal to each other. So my next step here can just simply be 30t times 200 equals 27t. All right, negative 200 equals negative 3t. That's a little silly. Let's multiply both sides by negative 1, so we end up with some positives. We don't get any negative time. 200 equals 3t. I divide both sides by 3 to isolate the t. My t is equal to, let me go ahead and throw that in my calculator. 200 divided by 3. My time is equal to 66.67 seconds. So I notice, assuming both continue to run at these speeds, how long will it take for the cheetah to catch the antelope? It will take 66.67 seconds, a little bit over 1 minute for the cheetah to get his dinner. I hope that makes a little bit more sense. I hope that's more clear. I'm focusing on the algebraic part because from the questions I saw in class, the graphing was fairly clear. But take a look at this. Let me know what other questions you have. I'm happy to also walk through the graph if that's your question. And I hope that helps. All right, have a good night.